So what I'd like to do in the next 15 minutes or so is to do three things, really. One is to argue that AI is nothing new. And Eri here did an excellent job of giving us an overview of the history of it. Then, a bit schizophrenically, I'll argue that AI is all new, because I think there have been some really important new developments lately. And finally, I'd like to give some tangible examples, both of what we at HP have done with AI over the last years, and also some maybe slightly broader ideas of where we see things going over the coming years. First, I'll spend 2 slides, and hopefully that doesn't exceed the self-promotion limit, on telling you a bit about HP. HP is quite a large company. We are a global company. We have about just short of 60,000 people working with us around the world. We hold about 28,000 patents at the moment, so very much a technology company. And what we want to do, what we care about, is to create technology that inspires ambitious and meaningful progress. So wherever there is a desire to progress in kind of ambitious and meaningful ways, we want to be there supporting our customers in doing so. Now, I'm from a particular part of HP, which is the large format printing business. We are based in Barcelona, in Catalonia. And we do a whole variety of product lines, from $1,000 printers for architects that can have them sitting on their desk, down to about $200,000 printers for manufacturing digitally printed textiles, or latex prints for signage, for things like vehicle wrapping, building wrappings, wallpapers, etc. We also do printers for professional photographers, fine artists. This is the DesignJet Z series. We have some software solutions, some cloud solutions. We also provide services. We really try to look after our customers in enabling them to make large format content accessible for everyone everywhere. That's really the mission that we have for ourselves. Now, this is the context in which I'll then show you the kinds of things we've been doing over the last years in terms of AI. And I'll be focusing on color. I'm a color scientist, a color technologist, and I'd like to give you some examples of what we have done using maybe some of the earlier AI techniques. I'll give you some examples that go back some years, and then we'll change kind of focus and look a bit ahead. Okay, so the kinds of things that we've been doing with AI, and here I really liked John's kind of criterion that the thing needs to, what we do needs to provide significant return on investment. If it doesn't, if it's just a marginal improvement, no one notices it, it's not really worth our time doing so. So one thing that we have done early on, and for these examples that you see in the first part, there are always references to published literature in peer-reviewed journals, so you can follow it up if you are interested in the subject. One thing that we have done using genetic algorithms and also greedy search minimization, which are some earlier forms of AI, is to pose ourselves the question of whether we can significantly reduce the amount of measurement needed to characterize the color output of printing systems. And what I'm showing you here are 3 images. The image in the center is what you get when you print a job on the basis of having measured about 2,000 color patches and then built color resources on that basis. On the right is what you get if you only use 27 measurements, but if you've optimized the choice of what those 27 measurements are. While on the left, you use still the same 27 measurements, but unoptimized, so just evenly spaced throughout the color space. And you can see the greater similarity between the really carefully controlled print at the center and the optimized 27 measurement-based result on the right, as against the unoptimized result on the left. And this has clear benefits for our customers. They can print fewer patches, they use less ink and media to get ready for production. Another thing we have done, and I don't know how clearly this comes across from the screen, is to use RANSAC. This is random sample consensus. It's another AI technique, combined with a conventional psychophysical model of how we perceive graininess in print, and also coupled with a new control paradigm we've developed at HP to significantly reduce the graininess of prints. And I think this is an important example in that the best solution for a certain problem may not be just taking one of the well-defined AI techniques and throwing it at the problem, but it may require other combinations of both AI techniques, more analytical or first principles models, as we've used in this case for grain, and also importantly, an appropriate way of controlling print systems. Because the assumptions that the various models, whether AI or not, make typically assume some kind of regularity in the response of a printing system to the data that we send to it. If the system is not controlled in such a kind of predictable and well-structured way, then these models struggle more or may not perform as well. Another example is to go after making the printing process more resource efficient, of involving the use of less ink when printing the variety of content that our customers print. And here we've used linear programming techniques, again, on the basis of the pixel control paradigm that we've introduced at HP, to significantly reduce the amount of ink, where on the left-hand side you see a number of colors spread through the range of colors printable on a particular system, its color gamut, and the size of the circles is the amount of ink used to match each of the colors represented. Instead, what we can do is go beyond the point that's on the left, which is the sort of theoretical minimum that you can achieve by adjusting color profiles, and we can undercut that by about 18% by taking advantage of a very different way of controlling the printing system, coupled with computational optimization. And the last example I'd like to show you is the most recent one, where it's about how to efficiently control color in printing on textiles that have been pre-dyed. This is quite a typical use case, especially in applications like sportswear, where you don't print on white textiles, but on pre-dyed ones, on a gray one or a green one, etc. And the challenge in production here was that every time a different pre-colored textile had to be printed on, the whole color characterization process had to be repeated. And what we did here is we used some supervised learning and deep learning algorithms to characterize the relationship between color on these different pre-colored substrates. And just to show you how different those results are on the different substrates, on the left you can see measurements, and this is spectral reflectance for those of you who work in this area, of a variety of ink combinations on a white textile. Instead, on the right, you see what comes out on a blue textile, right? As you would expect, if you print various inks onto a blue substrate, you're going to get a much lesser variation of colors, but you'll still want to hit a specific color that's accessible to you when you print on a blue base, and you want to know what combination of inks results in that. And again, instead of having to measure everything for every particular case, you can characterize how these different systems relate, and you can use AI to learn those relationships, which would be difficult to define from first principles. So these are just a kind of a couple of examples of things we have done, very specific, and they really fall into this category of using AI for very narrow applications that has been mentioned before. Maybe one thing I'd underline is that even if the application is a narrow one, the AI technique is still general purpose, right? So you've trained it for a narrow case, but you've trained something that wasn't really meant or designed for this particular application. It's a general purpose technique, but because of how you've trained it, it solves a very specific, narrow problem in some sense. So all of these are examples of AI-based solutions to specific color-related printing challenges. And now I'd like to sort of turn the page and think about what I see is coming, in the next years. Again, in this kind of context of color in printing. And I think sort of the headline for me is a move of going from AI components in addressing the variety of challenges we face to really an AI infrastructure. And I'll try to give you a sense of what I mean by that, by giving you a sense of what might compose an infrastructure like that. And clearly, since this is in the future, it's hand-waving, and I'm not saying that we are going to do all of this stuff, but just to give you a flavor of the kind of landscape that we see ahead of us. So I think there are kind of a couple of things that have been going on over the last 2 years or so. And I think one of them is really a change of what AI does within the broader IT landscape. And I think we are moving in a direction where AI becomes the new compute, the new way in which computation is performed. And effectively, every print transaction will involve one or more AI systems or components in obtaining it. The other thing that I believe is already happening to some extent, and I think will happen more, also with recent efforts by OpenAI, NVIDIA, and others, is that these models, which today we have to access in specific ways, maybe through a subscription that are quite kind of time-consuming, will become ubiquitous. And what it will mean is that these very large networks with more than 1 billion parameters will just become part of the toolkit of technology that you can throw at whatever problem you want to solve. We've had some great examples here already of what might be possible with these generative AI techniques, and I'll give you a couple more in a moment. Then also we've seen great examples already today about the use of generative AI to create content, and this really resulting in a content explosion. And for us in the printing industry, I think that the great thing about it is that a bunch of that content will eventually be printed. So there's more stuff that will be printed, and therefore, we need to be in a good position to receive it and to print it well as well, which is maybe an aspect we haven't spoken about so much. Are there things that we can do specifically to make the printing of AI-generated content favored or to make it come out particularly well? And then finally, and again, this relates to recent developments in natural language processing with the large language models, there's a move towards the control over the printing systems, whether they be in the home, the office, or in an industrial setting, being via voice and language interaction, and maybe taking away some of the challenges that we certainly see in large format printing, which is essentially a de-skilling in the workforce that uses our machines, and therefore the need to make them more automated, more easy to understand, more easy to use. Okay, so let me now give you a sense of where I think we'll be heading in terms of the new things that we'll be doing with the more recent developments in AI. And one of them, I think, is going to be in the area of content correction. We've had some examples of it already along these lines in terms of resolution, in terms of adding content for bleed, but I think it will go even further than that. And effectively, the main type of technology that will support this type of functionality will be generative adversarial networks. Again, we've heard about them already today. And what I'll show you is a couple of examples and always a sense of focus on the data, which has also been quite clear today, right? So we can get a lot out of using AI, but there's always a prerequisite for having the right data from which AI can understand latent or complex relationships that maybe a human user or operator will struggle to identify. So imagine that you have examples of input content and then content that has been corrected maybe by an expert user. With generative adversarial networks, you can extract the corrections that were applied and apply them to new content. And even things like coloring black and white content to turn it to color, or changing how vivid or impactful content is the kind of correction that will be performed automatically. Then the color profiles that are used to control the output of various printing systems, or even the color content of individual jobs, can also be optimized. And again, on the basis of using reinforcement learning techniques or other machine learning solutions. And here, instead of having the examples that we saw in the previous case of original and corrected jobs, another basis for making these adjustments is just to print content as it is received, and then also keep track of the adjustments that get made. Imagine that you send a print job to production and it doesn't come out right. If you keep track of the adjustments that were made to fix it, then you can use those adjustments as the basis for reinforcement learning to understand how jobs need to be corrected and what state they are kind of optimal at. And another important element of this kind of future infrastructure is also automated image analysis. Again, we've had an example of that previously, where we can use convolutional neural networks to identify features that lets us identify what state some content is in, whether it is good to be produced, whether it needs to have some adjustments made to it. a next element that we've also heard about already is the use of computer vision to inspect the output of printing systems. And again, on the basis of previously annotated print jobs. Imagine if you are, again, producing some content and you have your quality assurance team identify issues with previous prints. If the data is captured and the jobs, both the intended one and the one that has the issues, is imaged with some camera system, then that can again be the basis for understanding the nature of those issues and identifying them in future prints. And then the final one of these pieces is natural language processing. And here there's been a real explosion of large language models recently. And what this will allow us to do is to not control the way that our printing systems and manufacturing facilities operate by adjusting parameters, tweaking knobs and sliders, but by using natural language in written or spoken form. And the basis for training a system to be able to be controlled in these ways is, again, data where you have the verbal expression of what you intend and an example of the output that got generated. Also, broader training data about the cultural, emotional associations to colors so that an operator can then say, make the print more impactful or make it look more classy or more vivid or smoother. No, we've had smoothness mentioned here earlier today. But for a system to be able to understand what is meant when we use natural language in this way, again, there is a prior need for having examples of what these verbal descriptions and color content correspond to. All right, and then, so we've looked at individual pieces, but I think where things will become really interesting is once they act together as a whole infrastructure. Instead of saying, I have a computer vision system or I have a way to optimize color profiles, which you can do already today, what will become really a game changer in the printing industry is when all of this acts together. So imagine a system where you have a print job that you see on the left, and what happens to it when you hit print is it gets analyzed. Then maybe based on the analysis and even based on some semantic color understanding and some verbal inputs from an operator or the customer directly, the print buyer, it gets adjusted. Then even the color profile that's used to drive the printing system is optimized, again using various AI techniques. And the output of that is further adapted, maybe based on the state of the press or the printing system on which you're going to produce the content. Then the output is checked, again using an AI quality control system with potentially real-time adjustments made in a production context. And all of this based both on the AIs that are trained appropriately on the variety of data I mentioned in the previous slides, and importantly, also based on the input of sensors. I think sensors is one of the kind of unspoken prerequisites for deploying AI, because it's going to be a source of data on which you can act, in addition to the data that you required to previously train these AI systems. And having the infrastructure for automatically deploying changes, so both an automation infrastructure, the availability of sensors, will then really enable all of this AI infrastructure to take you from content that is not in the best state for production to delivering successful prints that customers would appreciate and that will make the whole production operation more efficient. So in summary, and here I'm paraphrasing an earlier quote that you mentioned, Karis, I really think that AI is not going to replace print service providers, but print service providers who use AI will replace those who don't. So I was really delighted when I was invited to this event by Marcus. I think it's great that we as an industry are alive to the opportunities and also threats. If we don't take the opportunities, they turn into threats. And I look forward to seeing what we do next. Thank you.
Thank you.